Hi Vinay, good evening. Let's wait for 2 more minutes and we can start. Ashish, good evening. Okay, Ashish. I guess we can start. So in the last class, we have discussed about the mean, median, mode, and the measures of dispersion, right? So I've given you some homework. Have you guys attempted it? We have less crowd today, and we can discuss that in detail. If you have done it, if you have any doubt, it'd be great. It's a good chance to learn. Ashish, Vinay, any of you? No? Okay, Vinay, great. And from your side, Ashish, okay, so you guys are okay. You are not around, right? Cool. But you are aware about the methods, measures of dispersion and central tendency. Cool. Then we are good to go. Okay, then let's start with the next topic that we have. Okay, so it's kind of an important one, and we generally uses this, in most of the data science use cases, right? So let's move to the next slide. Today we'll be talking about the quantiles, right? So you all are aware about the median, right? So median, let me give you a quick hint what it is. What is median? if we, think in terms of quantiles, then middle is nothing but your 50th percentile. Okay, I'll show you how it is. Okay, let's start with the very basic. So if you see the definition is saying basically a quantile is a statistical measure that divides a data set into equal sized intervals. Okay, so it helps us understand the spread of the data by showing where certain proportion of the data lie. Okay, so there are a few types of quantiles that we have. Okay, you can see in the table we have quartiles, quintiles, deciles, and percentiles. So each is having a different number of groups, if you see here, right? And each quantile represents a cutoff in the data, where a certain percentage of data values fall in. Okay, so if we, talk about just quartiles, so quartiles will be having four number of groups. Okay, so we like if we are dividing our data sets using quartiles, then we'll be having four groups out of our data. Okay, each division or each segment will be having 25% each, right? Similarly, for quintiles, you'll be having five groups, for deciles 10 groups, and percentiles 100 groups. Okay, let's move to the next slide. And let me know if you have any doubt. Okay, you can stop me anywhere. So let's start with the first one. Okay, that is understanding the quartiles. Okay, so as I mentioned, it's a type of quantile only. Okay, so let's start with that. So you are aware, right? Quartiles divide the data set into four parts, where each part contains 25% of the data. Okay, the three quartiles are, okay, so Q1, the first quartile, or the 25th percentile. Okay, I'll tell you, like as we discussed, right? Percentile divide your data in 100 groups. If we move back to the old slide, right? You can see here percentile divides your data in 100 groups. It means 1% each. So if we are talking about first quartile, and here if you can see, right, we're dividing it in four groups, right? So it means 25th percentile is nothing but first quartile. Are you with me? Vinay, Ashish, you can stop me if you're not able to understand. Raini, Prashant, Rakesh, you can guys know. Any of you, want to have the context? I can repeat it again. What are we discussing today? What are we studying? Are we good to go? New folks. Vinay, you are already there. I'm asking the new members. I guess no one. So just a quick recap, guys. We were discussing about the quantiles. Okay. So we have four types of quantiles: quartiles, quintiles, deciles, and percentiles. Each type of quantile divide your data set in some sort number of groups. For quartiles will be 4, for quintiles 5, for deciles 10, and for percentiles it will be 100. Okay. So we were discussing about the first type of quantiles, that was quartile. So as I told you, each quartile divides your data set in 25 in four groups, right? So it means your data, each part will be representing or containing 25% of the data, right? So we have three quartiles. First quartile, it means 25th percentile. As I explained, percentile divides your data set in 100 groups. Okay, so 1% each segment. So first quartile is representing your 25th percentile as well. So the value below which 25% of the data fails, it basically when we are saying Q1, it means we are representing the data set that falls below the 25%. I mean, in the first segment of your data. Okay. And when we are talking about second quantile, that is the middle value, splitting the data set into two halves, right? So second quartile is nothing but the 50th percentile or the median, as I told you when we were starting. Okay. So if you like, what was median, right? We used to, represent our number, all the numbers that we had in order, right? And then we used to pick the middle part of it, right? Same thing is happening here. If you take the 50th percentile, it means you are taking the middle value out of it, right? It means we are talking about the median here. right? Are you with me so far? I guess you all are. Okay. Yeah. So let's talk about the third quartile. Okay. Third quartile is nothing but your 75th percentile. It's simple math. 25% first quartile, 50% second quartile, 75% third quartile, 100% will be your Q4. But generally, we can use Q3 as our benchmark. Anything above Q3 is your Q4, right? So that's why we don't, generally use Q4 as terminology, because we are able to say, like, identify that part just by Q3 only. Okay. So if I'm saying Q3, it means Q3 is representing value below which 75% of the data falls, right? But if I want to represent Q4, I can just say anything above Q3. Are you with me so far? I'm taking this as a yes. Okay, so let's take example. Okay, example of quartiles. Okay, consider this data set ordered from smallest to largest. Okay, so one mandatory criteria that was also there when we were calculating median, right? What was that? We used to order our data set from smallest to largest, right? So same thing is happening here. It's pre-ordered 5 to 50, right? So if we try to find out the first quartile here, what will it be? Anyone can tell me a random guess based on the definition that we just learned? Guys, you can unmute yourself or you can write it in chat. I'm fine with both.
The first quartile will be 25% of the number we have.
Yeah. So from this example, how can we identify that? Okay, so it's simple math. We'll just take the 25% of the data set, right? That is basically the first three values, because we are having 10 values here, right? If you count 3, 6, and then 10, right? So Q1 is basically nothing but 5, 10, and 50. So here Q1 basically represent a number, okay, below which all your values will fall. That, like, the 25% of your data. Okay, so here what Q1 is representing? The 25th value here, 25th percentage value here, that is nothing but 15th. Okay, first quartile means 25th percentile, and that is the value is 15. Okay, if I'm giving you a number, okay, just think about this array only that you have, and I'm saying, okay, your Q1 is 20, right? So out of this array, you can tell me what all are values that are below Q1. You can simply tell me, right? And how many values are there below Q1? So,
There are like
see,
three values, right?
yeah. So that basically gives you a very good idea about your data set, right? So when when we'll discuss the distributions, right? Then you will understand how we identify the outliers using our quartiles, right? So if I'm saying, you have extreme values in your data set, right? So generally what we do, we take something around, like, the benchmark is could be 95th percent, anything above 95th percentile. Okay, I'll just simply drop them. Okay, so these methods of calculation helps us to identify the extreme values, right? It basically gives you the picture about your data as well, like what kind of values are there, right? Okay. Similarly, if I'm asking you to calculate the second quartile, it means the middle part of it, 50th percentile or median. You can simply tell me median of this array, right? Can you? Okay, let's have a quick test here. We have a even number of elements here, right? Just give me a quick median value of this array.
Like 25 plus 30 divided by 2, 27.
Great. Yeah. Okay, it was already there. Great. But okay, yeah. So what we used to do when we had, like, have even numbers, we pick the middle two numbers and take average of it, right? That will be our 50th percentile or median or Q2. Q2 basically we represent quartiles with Q1, Q2, and Q3. Okay. So Q2 is nothing but your 50th percentile and median. Okay, so are you with me so far here?
Yes.
Great. Okay, similarly, we have Q3 here, that is nothing but the third quartile and the 75th percentile. Okay, so it means the first 75th% of your data will fall below that. So here in this case, what is the 75th percentile value here? That is 35, right? 75% of your data set. So if I'm talking about Q3, so quartile third, so 35 is representing your Q3. Okay, let's move ahead. If you have any doubt, you can stop me. I am giving you 30 seconds. Okay, great. Let's move to the next slide. So now we have one very important topic, that is interquartile range. Okay, so interquartile range, right, measures the spread of the middle 50% of the data. Okay, so it's nothing but the subtraction of your Q3 and Q1. Right, Q3, what was Q3? Q3 is your third quartile, Q1 is your first quartile. So if we take the previous example, right, so what was Q3 there? 35. And what was Q1 there? 15. So it's the difference of your third quartile and the first quartile. Any doubt here? Okay, no. So it so why is IQR important, or in interquartile range, right? So it basically helps us, to detect outliers. We'll be using this when we'll be solving our data science problems, right? A large IQR indicates more variability in your data set, right? You all understand, right, what is variability and what is more variability, right? When we are saying variability, your data set is having high variability. So what does it represent? Can anyone tell me? Okay, Prashant, no, you don't understand that. Did you miss the last lecture?
No, for the last question, I told no. You asked no any doubt so far. That's why I
Acha,
remember.
okay, got it. Cool. Yeah. So I guess all of you understand what is variability in our data set, right? Cool. So if we are having a smaller IQR, that is nothing but interquartile range, suggests that our data is closely packed around the median. It means our data is having very less variability. So it means your measures of spread, right? Measures of dispersion will be having very less value. All of you with me so far? Great. Let's move to the next slide. Okay. So I think I've already covered, right, what are percentiles, right, when I was trying to explain the quartile, right? But let's have a quick look on this. So what is a percentile? Like when we were discussing it, it basically divides your data set in 100 equal parts. Okay. So let's say if we have numbers from 1 to 100, so it means each number is a part of that group. I mean, each number is representing a percentile, right? One is first percentile, two is second percentile, right? Okay. So here, if we talking about 25th percentile, that is nothing but Q1, right? So same definition, right? If I'm saying this particular number is my 25th percentile, it means 25th 5% of your data set will fall below this number. Okay. 50th percentile is the center of your data, right? So it means 50% of your data will fall below this number. Okay. All of you with me so far? Any question here? I'm taking this as a no. Okay. Uh, so I guess the next like rest two are self-explanatory, right? It's 75th percentile and 90th percentile. What are we trying to say here? Just let's take the example of 99th percentile. Okay. Can anyone tell me what is 99th percentile representing?
The values below 99, those
Yeah,
are.
great. So it's that simple, right? Only the terms are difficult. I mean, the names and all, right? But if you understand the core of it, everything is very simple. Okay. So let's take the example. This is a very common example. Like you can imagine, okay, SAT score. We don't have SAT scores in India. Let's take CAT score. Okay. So imagine CAT scores for 1,000 students. Okay. So a student is scoring in the 80th percentile, right? So what does it mean? Any random guess? Don't read on the screen, and you can make any random guess what it is representing. Okay, so it is simply basically simply saying that that particular guy, the student that we're talking about, he has scored more than the 80% of the students. Okay, and he is like left with the remaining 20%, right? So it means he has scored lower than those 20% segment, right? So in most of our colleges, and if we attempt these kind of competitive exams, generally we get percentiles at the end, right? They select it based on percentiles. So that's how they calculate it. So whenever we are saying that I am like generally people say, okay, I am in 99th percentile, right? But we don't know like what is that 99th percentile is representing. Okay, so let's say that exam is of 100 marks. Okay, so don't get confused with 100 marks and 100 percentile. Okay, so let's say most of the students, 99% of the students scored below 90. Okay. And only one student has scored 92 or 93. So he's in the 100 percentile, right? He's the topper there. Okay. So it does not mean that he has scored 100. He has scored the maximum marks. All of you understood this? Nice. Yes, no. Okay. Cool. Let's move to the next slide. Okay. So formula for finding a percentile, I think I should not tell you. It's very that simple, right? It's basically percentage calculation. Okay. So let's take one example here. Okay. Now all of you can try to solve it, but already on the screen, right? I'm asking you to calculate 60th percentile. Okay. So pth percentile is 60, 100 is your number, and n is the total number of samples that you have, right? So if I'm saying P60, if I'm asking you to calculate P60, just replace this P with 60, divide by 100, and multiply the total number of samples that you have. So it is telling me 6. Okay, now you can count what is it, what is your sixth value? 1, 2, 3, 4, 5, 6. So here in this case, sixth value in your ordered data set is 75. So basically, what is your P60 here? That is 75. Okay, any question? Cool. Don't worry, I have a lot of questions for you at the end of this session. Okay, so now let's talk about the key differences between quantiles and percentiles, right? I think all of you know, right? I've already explained, but just have a brief look on this. Okay, so what is the major difference? That is the number of divisions, right? So your quantiles, right, basically, spatially quartiles, right, divides your data set in four equal parts. Not four equal parts, four parts. Okay, your percentile divides your data set in 100 equal groups or parts. Okay, the common types, the quartiles, Q1, Q2, Q3 quintiles, one first to 99 percentiles. These are basically the types, like the group we are talking about, right? Best for. So if you want to understand a broad distribution, right? Because if you divide your data set in four big groups, right, you'll be having bigger chunk of the data. But if you divide your data set in 100 small groups, you'll be having lower chunk of data. So comparing individual scores within a data set, right? I've given you the best example. comparing the marks, right? So that's one of the example. Okay, let's move ahead. Okay, so real world application of quantiles and percentiles. We were just discussing about it. Let's take few examples, right? So first, target the education industry. That is, we will be having exam scores and student rankings here. School often reports student scores using percentiles. I gave you this example, when we were talking about the CAT score and all, right? So if a student is in the 90th percentile on the SAT, it means he scored higher than 90% of the test takers. Okay. Let's take example of healthcare here. The growth charts and medical charts. Doctor use percentiles to track baby growth. Okay. A baby in the 25th percentile for height is taller than 25% of other babies, but shorter than 75%. Right. So these are the few examples. If you want, you can start like read it out. Right. I'm giving you 1 minute. If you have any doubt, you can tell me. Okay. We'll resume on lecture after 1 minute. Okay. I guess we are good to go. Anyone still reading the examples? Okay, I guess no one. Let's move to the next slide. So yeah,
Can you please show me the question? 25th. So a baby in the 25th percentile for height is taller than 25% of other babies, but shorter than 75.
correct.
Okay, then the position which present this it's different. He gave the statement, right? Do you want us to analyze, or is normally analyzed and kept, right?
Sorry, come again. Can you speak louder, Vinay?
My voice is not good. Yeah, you go ahead. Go ahead. Later, I'll ask. Just I'll keep in mind. Also,
Okay, okay,
next
sure.
go to next slide.
Yeah. Okay, so it's the same thing that we have discussed in our last slides, right? So it's just basically the summary of all the key concepts, right? So quantile, a value that divides a data set into equal size groups, right? Example, quartile, divide data in 4 equal parts. Quartile Q1, Q2, Q3, 25th, 50th, and 70th percentile, right? Q1 is basically trying to say the value below which 25% of your data falls. Q2 is basically trying to say 50%, the value below which 50% of your data falls. And similarly, Q3 is trying to say below which 75% of your data falls. I think when it can answer your question when we were saying the baby, right? So a baby in the 25th percentile for height, right? So it basically representing a number 25th percent. So it means it is trying to say baby is taller than 25% of other babies that are in the first segment and shorter than the remaining 75% of the baby. Okay, it's similar as the score. Okay, so we learned about one more concept, that was interquartile range. So it is nothing but the difference of your quartile third and quartile one. Okay, percentile, below which percentage, like a value below which p% of a data falls, same as quartiles. There we have three numbers, 25, 50, and 75. But here it could be any random number between 1 and 100. Okay, so we can take example of 90th percentile, means 90% of a value falls below than this. Okay, decile we have not talked about, but it's the same kind of concept. It divides your data set in 10 equal parts, right? So here we'll be having P10, P20, P30, P100, P90 kind of thing. Okay, right. So let's solve some practice problems. Okay, now I want you to solve this. Okay, take your time. We'll be taking so for this is the easy one, right? But I want you all of you to write the answers for this. Okay, you have 3 minutes for this. 1 minute for each. If you take time, you will be wasting your own time only. So better do it quickly. Yeah, when two more questions are there in this ABCD. What about the rest of you? You are not solving or attempting the problem, except Vinay or Prashant. Okay, 1 more minute, and then we'll move to the solution part of it. Well, I guess we can move to the next slide. Okay, so here is now let's try to solve that problem. Okay, so the first question was find Q1, right? First quartile. That is nothing but the 25th percentile. Okay, so how will you represent the 25th percentile here? 1 by 4th, correct? Okay, so here 1 by 4th into n. N is nothing but the total number of samples there. I'm telling you the shortcuts. Okay, so basically just multiply 1 by 4 by 10, the total number of samples, you will get 2.5. Okay, since the position 2.5, position is 2.5, we can take the average of second and third value. Okay, similar as median. Okay, so what were the values at second and third? That was 50 and 55. So we are taking the average here. It's becoming 52.5, right? So sometimes we'll be getting an integer as well, right? A complete number, that time will be a single value. If it is not, right, when you are between two numbers, then you can take the average out of it. Okay. Now the second thing is find Q2, second quartile. That is nothing but the 50th percentile. Similarly, okay, I forgot to put the 1 by 2 here. This is not 12, it's 1 by 2. Okay. So 1 by 2 into n, one it means 0.5 into 10, it'll be fifth number, right? Since the position is 5, we take the average of the fifth and sixth values. Okay, 65 and 70. Q2 is equal to 67.5. Okay, now let's calculate the third per quartile, right? Similarly, 3 by 4th multiply by n, right? It'll give you 7.5 position, seventh and eighth value. We'll take the average, we'll be having this. In IQR, you all know, right? It's the difference between Q3 and Q1. That is nothing but the difference of 77.5 and minus 52.5. That is 25. Any questions so far, guys? So all of you are very close. It's not wrong. It's right answers only.
I have a question.
Yeah,
Like
sure. Go
we
ahead.
need to take the average of like we need to divide both of them by two if it is even, when like a number of data set is even.
Not even odd, no? You are not able to see. See, here what we are getting, it's not even odd thing, right? Here you are what you are saying, right? In case of median, yes, sure. Because in median, what is happening, right? You are not able to decide which is the centermost number here, correct?
Yes. Okay.
If it is even, right, obviously it is pretty sure. You don't have to.
Yeah,
Here the position is like 2.5. You took the average of second and third. When
Correct.
it comes to fifth, like fifth one also, you took 5 and 6.
So
When it
it's
comes to
one of the
7.5,
exception.
same
I'll tell you
next
why.
one.
So here we are calculating the median. Okay. So you remember, right, when we calculate median, right? In case of median, we take the centermost value, right? And here the total number of values we have is
Even
even.
10. Yeah, I got your point here.
Yeah. Okay. So do I have to explain or you guys understood?
Like 2.5 means you have to take the average of second, like next one, the current position and next one, right?
Correct, correct. Current and the next one.
Yeah.
2.5 means 2 and 3, the floor and seal of the number. Floor and seal, you guys understand, right? You must have learned this in the Python class.
yes,
It's
yes,
maths
got it.
concept.
I thought we need to take only the like seal of the number. That's why I write like
No, no, that's why I
2.5.
told you. All of you are right only.
Yes, yes.
Okay. It's the closest thing, okay? It's approximation. So don't worry. Okay, let's move to the next question. Okay, now we'll be finding percentiles. Okay, again, you guys have 3 minutes to solve this. We have three questions. Okay, I'm giving you a hint as well how to calculate. Rest can attempt it too. Sushant, Vinay, at least you should attempt. It's for your own learning. If you solve these questions, right, so you will understand, you will remember all these concepts. That's why I'm asking you to solve these questions. Otherwise, that I can just finish the lecture and close it. And I want you to keep it in your mind, like whenever you will heard these words, percentile, quantile, quartile, right, you will be able to calculate them. Thank you, Prashant. What about the third one? You don't have to write, you can unmute yourself and tell.
Like for the third question, it is asking for the which position that particular number is, or what is the number that is.
So it's the interpretation, like what it is trying to say. Like I've repeated this many times, right?
Yes, yes, sir. Like 172, that is that number. It is like greater than 75% of that particular data set. That's what.
Very close. Okay, let's move to the solution. Okay, so this was the data set, right? So 30th percentile that I've asked is like P30, the formula that I've given there, right? 30 divided by 100 into and 30 divided by 100. So we have 12 samples here. It'll be 3.6, right? Since 3.6 is between 3 and 4 values, so we'll take these two values, we'll take the average. So it is 159.
But
Very
the
clear.
seal was like 3.6, then it will be very close to fourth position, right?
Yeah, but generally, as I told you, it's approximation, right? So
Okay.
you can take both the numbers.
Okay.
Okay. So find the 75th percentile, same thing. We'll calculate 75 500 into total number of samples will be 9, right? So here it is an integer. We take the ninth value 172 exactly. I mean the exact value that you got, Prashant. Okay. So yeah. So the interpretation is a height of 170 centimeter means 75% of the students are shorter than 172 centimeter. Okay. So only 25% of the students are taller than this 172 centimeter height. That's quite close to our real world data set, right? 5758 is kind of a good height, right? And then you will find very few people above that in some like if you're talking about some states, and maybe it can be different. Okay, move. Can we go ahead? Any question here?
No, no,
Vinay, Prashant, anyone?
no.
Okay, one more question. So we have total 5 questions, and we will try to solve all of them. If this one may interest you. It's about salary. You guys try to solve this problem. Meanwhile, I have some water and come back. Third question is very important, and you will find this in your data science problems, right? You'll be having this kind of outlier, and then how will you find it, like, and how will you remove it, or the strategy, right? So these kind of things helps you to solve these kind of problems. When I'm Prashant, I'm expecting you to answer this question, especially the C part of it. Okay, now let's move to the solution. Okay, so this was our data set, and the step one, the question was find Q1, Q2, and Q3. Right? We all know how to calculate Q1, Q2, and Q3, right? So Q1 is 1/4 of uh, the total numbers, that is 16. It will be 4. Q1 equal to 45, right, Prashant? And then uh, Q2 is equal to 1 by 2 into 16, 50th percentile, it is 8, right? 55, it'll be 56 as well, Prashant. I sure you have taken the average, right? 56.5. Okay, Q3 equal to 3/4 into 16, it's becoming 12. 12, 12 equal to 73, Q2 equal to 73. The IQR was the difference of Q3 and Q1, that is Q3 minus Q1 equal to 70 minus 45 equal to 25, right? Nice, it's correct. Okay, now let's come to the interesting part, right? Adding a very high salary, 95K, will not change Q1 or Q2. Can anyone tell me why it will not change Q1 or Q2?
Less than two values, so that's the reason.
Yeah, but it will slightly shift Q3 upward because it basically we are reaching toward that segment, right? So that's why. So so for HR application, the IQR 25K spread in your salaries. So helps HR understand pay gaps and decide fair salary structures. That never happens, but yeah, we can at least she will HR will have some idea, right? What it is what's happening in the company, right? What is the spread in the salaries? Okay. This was kind of a real world application example. Let's move to the next question. So here we are trying to detect the outlier using IQR. So it'd be great if you can tell me. So we have a rule here. If you like read the C part, right? So that's how we calculate or identify the outlier. So these things will definitely help you in your data science use cases if you understand them, if you solve them. Third question is very important and we use it in real time or real life. Try to solve the third question. Okay, I'm giving you 2 more minutes to solve it. Right? It's just formula imputation, right? You can just impute Q1, Q3 and try to find out the outliers using these two rules. Vinay Prashant, others, please do it. It's for your own good. And this is one of the interview question if you are attempting for a data science interview. What is IQR, interquartile range? How it will help you to identify the outliers. So Prashant, you have when you have to use them to basically detect the outlier, lower bound and upper bound. Right? So using these two rules, can you tell me like Are there any outliers in our data set? Okay, let's move to the solution. Okay, so this was our data set 5 to 20. Q1 and Q3 we can simply find using our rules, right? So that is 6.5, 11.5. Yeah. Okay. So compute IQR Q3 minus Q1. It's coming as 5. And thanks, Vinay, for the answers. Okay. Now calculate outlier bounds, right? So the lower bounds is -1 and the upper bound is 19. Okay. So any value below -1 or above 19 is an outlier. Okay. So the value 20 is an outlier because it exceeds the upper bound 19. It's okay. It happens, Vinay. Okay. So any question here so far? Guys, this is the important concept. If you are not able to understand this, please let me know. It's very, very important. I'm telling you. Can be an interview question. And then most of the time, everything is an interview question. People can ask you mean, median, mode, right? Even the math measures of dispersion, what is variance, what is standard deviation, everything is gonna be a question in your interview. Okay, if you're attempting for a data science interview. So keep these things in mind. These are very important concepts. Okay, let's move to the last question. Okay, so try to solve this, and I'm giving you 2 minutes this time only. Okay, all the repeated questions only we have already solved, so just try to solve them as soon as possible. Okay, let's move to the solution part of it. Okay, so here I have not mentioned the steps here. Okay, so it's basically the direct solution. You can compare it. You know all the formulas, right? Q1 equal to 55, Q2 is 70. It could be here and there when, as I told you, approximated values Q3 85. IQR is the difference of Q3 minus Q1, that is 30. 80th percentile, that is P80. You guys know the formula, right? 80 divided by 100 into the total number of samples we have, it will become 85. And the interpretation of the 90th percentile, a student in the 90th percentile, that is score equal to 92, performed better than 90% of the class. Okay. Yeah. So now, like in the last class, we were, discussing about some graphs, right? But I want to give you some brief ideas of the graphs, right? When the particular graph will be helpful for you, right? When can you plot it? So we have some graph representation, the pie chart, the bar graph, histogram, frequency polygon, time series charts, right? It's important to choose the appropriate graphs to make statistical information coherent. Okay. So basically, if I'm asking you to, present something, right, you should know about a correct graph for that, right? So let's talk about the pie chart first. Okay. A pie chart graph showing the differences in frequencies of percentage among categorical or a nominal. Categorical, we have nominal and ordinal variables, right? So the categories are displayed as segments of a circle, okay, whose pieces are, add up to 100% of the total frequency. I'll show you what a pie chart is, then you'll get the idea. Okay. You must have seen this pie chart at many places, especially in cricket. If you see cricket, right? If you watch cricket. So here, if you see the circle, so what are white? So this purple, what purple color is saying here, right? So in this circle, so if we read this, right? So what it is trying to say, out of this number, let's say this is representing the population, or you can read it annual estimates of US population 65 years and over by race. Okay, so it is trying to say in US 87.7% people are white. Okay, 8.3% are black. Rest are difficult to analyze. So let's move to the next part where we have less number of classes. Okay, here if you see, we have only three segments. So the major category is 87.7%, that is white, 8.3% is black, and other and two more. So we have combined the rest of the classes in just one particular segment, right? We are calling them others. That is nothing but 4%. So here we are having total three categorical values in our data set, in our column. Okay, white, black, and others. Right. So it's again one of a method, to reduce the cardinality in your data set. Okay, so if you are having a lot of categorical values in your data, in your column, okay, so it'll be difficult you to use them as a feature. Okay, so what you can do, you can combine the smaller segment of it, right, where the percentage is like 0.2%, 0.1%, 1%, 2%. So you can make a bigger class out of it, like other, right? So let's say we can think, see, we have combined the other segment, right? The other segments in just one particular category, that is other. Okay. So I'm trying to give you the picture of your data science problem as well. Any question here?
No.
Okay. Yeah. Okay. The next thing is the bar graph. Okay. So a graph showing the differences in frequency or percentage among categories of a nominal and ordinal variable. Okay, the categories are displayed as rectangles of equal width with their height proportional to the frequency or percentage of that category. Okay, you'll get the idea what it is trying to say. Okay, now you can see here. Okay, we have this graph. Okay, so here the category, the in that particular segment, so we have two person, like with two options, male and female. Okay, so if you see the living arrangement of US elderly 65 and older by gender, so we have three segments here. One is living alone for gender male and female, and we have three segments: living alone, married, and other. Okay, so here we are showing what is the segment of male and female that is living alone here. So if you see this graph, just by looking at it, I can directly say, okay, most of the females compared to men live alone. Okay, here, and in case of married, right? So the count of male is more here compared to women. Okay, in other that we don't know here, male is lesser than female, right? So basically, if you have asked you to present data in this format, you can do it, right? When you trying to compare two particular segment for a type of a problem, right? Then you can show it like this. Okay, similar kind of graph, just a different view. Okay, the histogram that we saw in the last class, right? It basically shows the frequency or the interval ratio variable, right? It'll look like this. Okay, so age distribution of US population 65 years and over. Okay, so between 60 to 65 to 69, how many people are there, right? So this is basically telling you the frequency, right? The majority lies in this segment. Okay, the least one lies in the 95 plus segment. Okay, so this is basically giving you the idea how many people are there within this age group. Okay, so when a similar problem arises and you want to present it, right, you can present it in this format using the histogram. Okay, same thing. Now the frequency polygon. Okay, a graph showing the differences in frequencies of percentage among categories of an interval ratio variable. You guys all know like what is the interval ratio variable. We are talking about numerical values here. Okay, you can see this. Okay, we will plot all these graphs when we'll be solving data science problems, right, in the data science classes. Right? I just wanted to give you the picture, right, how it looks like and when we use them. Yeah, time series part. So you can see, okay, percentage of total US population 65 years and over, like how it is increasing, right? So with time, if you're plotting something, so this is nothing but a bivariate analysis, right? So with time, if you see seeing something, okay, this graph is increasing, right? The population graph is increasing with time, right? So this is kind of this. Okay, if we divided male and female, right? So we have added one more category here, the hue basically. Now we have same graph, but for two categories, male and female. Okay. So why use charts and graph? Ability to examine numerical detail offered by a table, right? Because you cannot examine each and every record in a table, correct? Or in an Excel that you have. Potentially, the ability to see the additional relationship within the data, potential. Often we get caught up with in selecting colors and formatting charts, right? Simply format the table is sufficient. So, like, it's very difficult, if I'm asking, if you take this example, right, this colorful one, right? So if you analyze this, like using the Excel, it'll be very difficult to see it, right? To get a very bigger picture. So that's how graphs help you a lot, right? So that's why we make presentation. Okay. Anyway, you can analyze it using pandas and all, but better to go ahead with this approach. Okay. Yeah. So if you remember in the last class, right, when we were discussing the measures of central tendency, right, we were discussing about the skewed distributions. Okay, we will read about distributions in detail. Okay, but I want to give you a picture about skewed distribution, and we will talk about skewness and kurtosis in today's lecture as well. Okay, so in a positively skewed, okay, so first, if you see the center part of it, this is a symmetric graph, symmetric distribution. Okay, so what will happen in a symmetric distribution? Your mode, median, and mean will be same. All three will lie in the center of a distribution. Okay, but if it is a positively skewed distribution, so your mode will come at the last. So it's like this. Your mean is greater than median and median is greater than mode here, right? Because we are going like this. Okay, understood. Similarly, in a negative skewed sample, right? Your mode is the maximum, median less, and then the median is smaller than mode and mean is smaller than median. Okay, any question here? Anyone? Question?
No. No.
Okay. Yeah. So now we have already seen like what is skewness, right? So now let's talk about skewness in detail. Okay. So skewness is nothing but a measure of asymmetry of a probability distribution. Okay. So this is nothing but a probability distribution that we were talking about, the frequency distribution. Okay. It tells us whether the data is skewed to the left, that is negative skew, okay, or to the right, that is positive skew. Okay, or if it is symmetric, that is no skewness in your data. Again, it's a interview question. Okay, people ask, right, what is the how the left skew distribution looks like and how the right skew distribution looks like, and how will you identify it? Okay, so make a note of it. This is very important. Okay, so we have three types of skewness. We have already discussed, right? Positive skew, negative skew, zero skew, that is symmetric graph. Okay, so what is the method to identify the positive skew? So tail is longer on the right side. If we go back, if you see, we have a longer tail here. Okay, can you see this? Let me annotate it. Okay, what is this? Can you see this part here? This is the longest, the tail is longer here in a positively skewed distribution. Okay. And most data values are concentrated on the left side, right? So if you see the graph, that the major graph is on the left side of it. Okay, so that's how you identify a positively skewed distribution. Okay, example, income distribution. A few people earn very high salaries while most earn less. So this distribution is perfectly suited for us in a salary example, because if you see, high earning individuals will be very less compared to the low earning individuals, right? All of you agree? Let's move to the negative skew. So the identification of a negative skew distribution is tail is longer on the left side, right? So if you see here, you have a longer tail, right? Most data values are concentrated on the right side of it. You can see it. Most of the values are concentrated on the right side of it. Okay, so it's the opposite of positively skewed. So, okay, exam score. Most students score high, but a few score very low. Okay, so the population that is scoring, I mean, the students that are scoring very low, I mean, that are getting grade E or less, right, will be very less, right? So this distribution is well suited for that kind of example. Okay, zero skewness. So data is perfectly symmetric here. So here, if you'll be having mean median mode on a single axis, or all three will be having the same value, the equal value. Okay, so the perfect example of this distribution is normal distribution, Gaussian distribution, right? Any question so far?
No question.
Okay, others, what about others? Can we go ahead? Vinay, Prashant? Okay, yeah. So let's have a look at the graphical representation of skewness, right? We just saw, right? I just wanted to show you the clear graphs, right? That was a little blurred. Okay, so this is looking like a symmetric distribution. Okay, if you see here, all the values are lying. You know, if you calculate mean, median, and mode, it will come approximately here only, right? So this graph is having a long tail on the right side, and most of the values are on the left side of the graph. It means it is a positively skewed graph, right? Similarly, if you see this one, most of the values are on the right side of the graph, and we have a long tail on the left side. It means it is the negatively skewed graph. Okay. So if I share the graphs with you, or anyone give you the graph like this, or anyone just ask you, right, how will you identify a positively skewed or a negatively skewed distribution? Will you be able to answer it? Yes or no, guys? Great. And trust me, it's a one of the interview question. Even I ask in the interviews. Okay. Let's move to the next part. Okay. That is kurtosis. Okay. So kurtosis measured the tailedness of a probability distribution. It helps in understanding whether the data has heavy tails, more outliers, or light tails. It means less outliers. Okay. So we have three types of kurtosis. One is mesokurtic, other one is leptokurtic, and the third one is the platykurtic. Okay, if a kurtosis is almost equal to 3, it means it is basically a normal distribution, that is a symmetric distribution. Okay, so it will look like a standard bell curve, moderate tails, right? An example is normally distributed test scores. Okay, but what is leptokurtic? Okay, so leptokurtic will be having kurtosis value greater than 3. It means heavy tail distribution. Okay, we will see the graphs, like how the graphs looks like for all these three examples, right? We'll be having sharp peak, heavy tails, right? I'm talking about the leptokurtic here. It will be having sharp peak and heavy tails. More extreme values, it means more outliers. Example, stock market crashes, high peaks due to clustering of values. Okay, the last one is platykurtic. Okay, in this example, you'll be having kurtosis value less than 3. The light tail, it means it's a light tail distribution, flat peak and thin tails. Okay, fewer outliers. Example, uniform distribution. Okay, let's see the graphs. Okay, so first one is almost the perfect distribution, right? So It's nothing but a mesokurtic, right? Moderate peak and tails. Okay, so it's like a moderate peak. It's not a sharp peak, right? And tails are like this. Okay. Now, if you see leptokurtic, where the kurtosis is greater than 3, okay. So see this. It's a very sharp kind of peak, right? Can you see the difference, right? It's like a normal curve. Here it's like going like a tower, right? So if you see sharp peak and heavy tails, right? The tails are like this, it's going for the sides, right? Meaning more extreme values. Okay. Platykurtic, where your kurtosis is less than 3, light tail, right? So flatter peak. Flatter peak looks like this. You can take example of mountains. Okay. A very sharp peak mountain is leptokurtic. Okay. Almost a rounded shape kind of mountain is mesokurtic. Platykurtic are, flat peak, right? Where you can walk at least, right? So that is nothing but a platykurtic, meaning few extreme values. Okay. Because all of them are looking like in the similar range. Okay. So if someone asks you, like how will you identify outliers using kurtosis? Can you do it? Okay, great. Nice. So let's summarize this skewness and kurtosis. So if I'm saying skewness is greater than zero, so what it is telling me? Positive skewness. So how will you identify a positive skewed distribution? Right? Positively skewed means right skewed as well. So you'll be having a long right tail, right? And the example can be income distribution, because if you the long right tail basically represent, right, we'll be having very few individuals who are earning more money, a lot of money, right? Skewness less than zero, it means negative skewness, right, or a left skewed distribution. We'll be having a long left tail. Let's say exam scores, as I mentioned, right? The students which are having below grade E will be very less, right? Skewness equal to zero, symmetric distribution, right? The perfect example is normal distribution. Okay, kurtosis greater than 3, that is nothing but the leptokurtic, right? Heavy tails, financial crashes. Kurtosis equal to 3, mesokurtic normal tails, right? Not going too much outside, right? Like the center one. Okay, and platykurtic, that is nothing but the kurtosis value less than 3. Okay, light tails, uniform distribution. Okay, so key takeaways from here. So it's kind of the end of the lecture, right? Any questions? We can take this remaining time for a Q&A. Or otherwise we can have, I'll have prepared a notebook for you guys. We can just check that as well if you want. But let's wait for, I want to wait for 2 minutes for Q&A. If you have any questions, please let me know. Okay, Prashant is not having any doubt. What about others? I'm assuming either you guys are very intelligent, or I'm teaching very well, so you are able to understand everything. So you
I think
can.
you are teaching very well. That's right.
Thank you, Prashant. Okay. So it's a very big notebook. We may not be able to finish it, but I just want to, show you guys a quick look, right? And if you want, I can share this with you. But like all of you are having some WhatsApp group.
Yeah, we have WhatsApp.
Okay, so I'll ask Anuj to share this file with you. Okay, I'll download it and share with him, and he will share it with you. Okay, let me share my screen. Yeah, to if it is, let me know if it's visible clearly or not. Can you see the Jupyter notebook?
We can see it, but it is not like clear.
What is the issue? Small or
We have to zoom it. Our screen. Prashant.
yeah? Is it better now?
No, we have to zoom it because it's a page content, right?
Yeah,
So web
Yeah,
page,
yeah,
we
okay, okay, okay.
can't
I'm
see that.
getting it.
If
let
we
me zoom
zoom,
it.
yeah,
Let me know if it is visible.
yeah, it's visible.
Okay, perfect. Okay, so it's the same thing, right? We talked about a population sample, right? So I just mentioned all those things here, right? So let's move to the visualization part of it, right? So I just want to, give you the hint, right? How we basically use this in the pandas notebook or Python, because ultimately we will be, these these theories, like we have read, like learned enough theory, right? You want to use it in the practical life, right? And you will be dealing with this kind of problems only. Okay, so let's say we have this data set that is adult data set, right? We have age, type of employer, I don't know about this variable, education number, marital status, occupation, relationship, race, right, gender, and a lot of other variables as well, right? So we'll be performing some analysis. Okay, if you see here, we want to print the counts, right, country wise. Okay, so we are performing a group by here. Okay, we are doing the group by on country, and we are just taking a size of it. So it's a shortcut to print the count, count the number of items country wise. If I just run it, you will get it, right? So we have entry here, question mark, it's a null value, right? So Cambodia is having 19 entities here, right? So it's basically showing you the count of employees country wise. Okay, so we want to, if we let's say if we want to see the same thing using age wise, we can do this again like this, right? We want to see, right, what is the count of my male employees. We can see like this, right? You can stop me if you have any question, right? I'm just giving you the glimpse of it. It will be solving this kind of problem. Okay, and if I want to filter, right, gender equal to male and income greater than $50,000, right, what will be the count of, what will the count? So it is coming as 666. Okay, so now let's separate male from female according to the income. Same thing we'll do for female as well, right? So how many females are there above $50,000, right, income, right? So that's how we will do it, right? We are doing the filtering here. Any question till here? Okay. Okay, so I wanted to tell you like this special thing, impute missing data. Okay, we are getting questions in chat here. No, no, no. Okay, great. Thank you. Yeah, so impute missing data is quite common, like we use mean, median, mode kind of values to fill the missing data. Yeah, I wanted to show that as well. Okay, where is my cursor? Okay, reduce dimensionality, add derived features, discretize numeric value into categories, right? We read about like how to identify categories and all, correct? So yeah, summarizing the data. First part is summarizing the data. Okay, so what we use to summarize the data? Okay, we take mean. Okay, so now let's say if I want to know the average age of men out of this data, right? So how will you summarize it? So you can just simply tell me the average age of men and women, right? So that is coming as around 40 years for men and 37 years for female. Okay, now the average in high income man is a high income woman, right? So simply you can have this. Okay, so we have all these values pre-calculated ML1 and F1, FM1, if you remember, right? We were trying to find out the male and female with who are earning more than 50.